Very good morning to everyone. So myself, P. Senthilraja. I'm working as assistant professor in the Department of CSE AIDS. Now I'm going to explain about the basic concepts and design and analysis of algorithm. So why do we use algorithm in computer science? So in field of computer science, the algorithms plays a major role. Okay, so I would like to say the basic definition for the same. So it is the step-by-step procedure to solve a simple or complex problem. So before doing any kind of programming, we need to categorize and we need to document your work so that we are going to use our algorithms. So algorithms, it has a precise rules that specifying how to solve a problem. The problem may be a simple problem or complex problem. So with the help of that some basic rules, we have to design an algorithm. So I would like to explain the basic concept, basic characteristics of an algorithm. So these are the important points to write an algorithm before start doing the coding. So actually the algorithm should be written in sequence. So which is mean that the algorithm should be start and it has an end, and between that we have do some process. Okay, then each and every instruction should be precise and unambiguous. So your algorithm should be very clear and that should be understandable to everyone. So each and every programmer should understand your algorithm clearly, right? So next, the instruction should not be repeated. The algorithm steps should not be repeated twice or thrice, whatever it may be. Okay, so then the ensure the algorithm will ultimately terminate. So your algorithm should be terminated, which means your program should be executed with the help of the steps to be followed in the algorithm. Okay, so next, how do we assign, how do we measure the quality of an algorithm? Because for a simple task, for a simple problem, we can develop n number of algorithms. So how do you choose the better algorithm? How do you optimize the algorithm, right? So the factors are accuracy, memory, time, sequence, and result. So accuracy in sense, for example, if you want to do any computational problems in that algorithm, there need to be declare some mathematical derivations. Okay, so that mathematical derivation should be applied in programming. That formula has been specified in that algorithm. That formula should be understandable one. Okay, so then memory. So memory in sense that how much space to be occupied to store your instruction, and time. The time in sense how much time taken to execute our algorithm. And next one is sequence. So sequence, it's nothing but it's controls the flow of your algorithm. Okay, so next one is result. Your algorithm should be produce a good results. So these are all the 5 factors to determine to choose your best optimistic algorithm. So next one is the representation of an algorithm. So your algorithm may be represented by several ways. So these are all the common ways. So with the help of basic normal English, you can represent or pseudocode or flowchart or programs. So normal English, it should be a grammatical, there should not be a grammatical mistakes, and that should be followed by sequence. And the pseudocode is look like a programming, but it's not actual programming, neither it not executed your program. So pseudocodes almost look like a program, so we cannot execute that pseudocode. Okay, so then flowchart. So flowchart is a graphical representation of your algorithm. So actually it follows some symbols, it has some rules to declare your algorithm. And programs, your algorithms may be represented with the help of some high level programs like C, C++, Java, whatever it is. You can represent your own algorithm with the help of any programming languages. So these are all the 4 ways to represent your algorithm. And I would like to share some topics in design and analysis of algorithm. So actually you have to calculate the performance of each and every algorithm. The performance may be calculated with the help of space complexity and time complexity. These are all the 2 factors to design a major algorithms. Okay, so space complexity is nothing but we have to how the instruction has been stored, how much space required to store your instructions, right? The instruction is nothing but actually it takes your memory in your computer. Okay, next one is time complexity. So time complexity, is used to measure your execution. Okay, actually execution time has been vary based on your input size. Your input size should be given in the time complexity to calculate the time complexity, and these are all the some basic mathematical notations to calculate your time complexity and space complexity. And first one is big O notation and omega notation and theta notation. So big O notation is used to analyze your complexity in worst case, and omega notation is used to analyze your complexity in best case, and theta notation it is used to analyze your complexity in average case. But anyway, we have to choose only the worst case analysis scenario, because worst case analysis we get a result of more than 90% probability, and in omega notation we use best case complexity, but it gives only 50% of the probability, and theta notation only we can get 10 to 20% of the probability. So as per the probability we can take big O notations. Okay, so next, these are all the basic concept which we are going to discuss in analysis of algorithm. First one is disjoint sets, and this is used to how to divide your sets with the help of graph and trees. And next one is graphs and trees. We can these are the representation of your storing and processing your nodes or data or elements, whatever it may be. Okay, so with the help of graphs and trees we are going to retrieve your data. And graph traversal techniques, so there are some techniques to traverse your node, which is already stored your elements with the help of graph and tree. We are going to retrieve the data with the help of these techniques. So basically in graph traversal techniques we have breadth first search and depth first search. The two techniques are really used. And tree traversal techniques we have in-order traversal and pre-order traversal and post-order traversal. So three techniques comes under your tree traversal techniques. And spanning trees, so actually spanning trees is used to find the minimum short in the graph. Okay, so these are all achieved by with the Kruskal algorithm and Prime's algorithm. So next one is binary search. This is one of the searching technique used to search your data inside your trees. Okay, so next one is sorting techniques. So we have discussed about we will discuss about merge sort and quick sort algorithms to sort your data. That's it, and thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.